So we're going to go ahead and subtract these two fractions, and this is a bit more difficult than the one with unlike denominators we've done before because our denominators are a bit more complicated. And rather than just jumping into, okay, let's multiply by the opposite denominator and call it good day, we need to think about this problem in a slightly different way. Instead of adding 1/2 and 1/3, we're more like adding 1/2 and 1/12 in this problem. Let's actually go ahead and subtract 1/2 and 1/12. Not add. I'm doing a subtraction problem. So when we look at this, we have a basic understanding. We know that 2 is a factor of 12, which means I can turn 2 into 12. And so I can multiply this fraction by 6 over 6 and then just get 6/12 minus 1/12 equals 5/12. And so that's a lot easier than multiplying one by 12 and the other by 2 and then simplifying at the end. And if you'd like, let's compare that. Let's go ahead and do that again the other way. So 1/2 minus 1/12, and we'd multiply this one by 12 over 12 and this one by 2 over 2, which will give me 12 over 24 minus 2 over 24, which is 10 over 24, which then I have to simplify to 5/12. And while that doesn't seem like a lot of extra work, it really is when we come to algebra because we're dealing with that final simplifying step, which is much harder. So we're going to go ahead and use this as our example, but kind of set it over here. So when we're looking at this problem, it's less obvious how I can turn x minus 4, or if I can turn x minus 4 into x squared minus 16. So before we get started, let's go ahead and factor. So this one's going to stay exactly the same. And then this one will become x minus 9, notice I put that in parentheses, over x minus 4 and x plus 4, because that's how x minus 16 factors. Oh, well, if I look at my factorization, I've got x minus 4 and x minus 4 over here, and then I have this x plus 4. And if I go back and think about this one, 12 is 6 times 2, so that's why I multiplied this by 6. So what would I multiply by in this problem? Well, I'd multiply this equation by x plus 4 over x plus 4, which again is still just 1. I'll move my multiplication sign over. And so we'll go ahead and distribute. Now I'm going to be really careful here, and I'm going to go ahead and distribute 3x plus 12. But I'm also going to, at the same time, since it's subtraction, distribute my minus sign, giving me negative x plus 9. We've got to be really careful with that subtraction piece. So then I write my denominator as x plus 4 and x minus 4. I combine like terms in my numerator. I get 2x plus 21 over x plus 4 and x minus 4. I notice that nothing can factor out of my numerator other than 1, so I am finished. And there's my answer. So think about, I'm not going to do the other way because it is so much more complicated. If I had multiplied by both of them, because eventually I'd have to factor and cancel, and it would get complicated. We know how difficult it can be to multiply x minus 9 times x minus 4, which will give me x squared minus 13x plus 36. Anyway, you don't really need to know that, but it gets really complicated, and then the minus sign gets more complicated, and everything kind of goes together. So we want to kind of keep in mind when we can take a shortcut like this one, instead of doing the whole problem and only multiplying one fraction instead of both, because it is much harder to multiply both.